Today we start our third section of 2.2, which is on normal distributions. Today we're going to transition into, can we assess if something is normal? If I give you a set of data, can you tell me if the data is normal or not? There's going to be various methods we can use to talk about normality. Now, the first one is we could easily just make a histogram of the data. Okay, if you make a graphical display, that's going to show you if it has approximately the right shape. So here are the measurements listed below. Describe the usable capacity in cubic feet of 36 side-by-side refrigerators. Are the data close to normal? So again, the first thing you could do is you could make a histogram to see if visually it looks normal or not. So for that, we are going to use our fancy calculators. So, oh, I'm sorry. All right, so let's take a look at our calculator. Now, I've already typed in all the data into list one. So if you need to do this, why don't you pause the video, list all those numbers, put them into list one, and then restart the video so you can follow along. Now, we talked about making a histogram in chapter one. Remember, any graphical display is going to be in stat plot. So I'm going to go into stat plot. Need to go into the first one, turn it on, change this to histogram. It's already pulling from list one, okay? So now I just have to zoom stat or zoom 9, and there we go. Now, for normal data, what are we talking about? Well, normal data, we're talking about that nice bell curve, okay? Symmetric and bell-shaped. And if you take a look at this, if I were to just draw a density curve over it, while of course it's not perfect, I definitely do see a bell shape to this, okay? I can see the symmetry and the kind of bell-shaped nature of it. So I would say based on the histogram, it is possible that this is coming from normal data, okay? Now in your note packet, you'll notice that I have a spot for you to sketch this, okay? Now I've already taken the liberty of labeling the axes for you, so all I need you to do is use your trace button, and then you can see for each bar what the width of the bar is, how far it's spanning, and how many elements are in it. So you can scroll from bar to bar. And I'm not going to take the time to do this in the video because we know how to make histograms. But I do want you to sketch it for me, okay? Put the appropriate scale and the appropriate heights based on this trace feature on your calculator. All right? So from there, let's talk about the next method, okay? So the next thing we can use is the empirical rule, okay? So remember, the empirical rule says within one standard deviation, we should see 68% of the data, or roughly. Within two standard deviations, we should see roughly 95% of the data, and within three standard deviations, see 99.7% of the data. Almost all of the data should be within 3 standard deviations. Now to do this, we obviously have to know the mean and we have to know the standard deviation. Now, the cool thing is, with all this data in the calculator, we actually can already find that information. If we just go into stat and we one variable stat that, that's exactly where we can go to get this information, okay? So, our mean is 15.825. And our standard deviation is about 1.217. All right, now looking at all the data, it only goes to 1 decimal place. So I'm actually going to round these off to have just 1 decimal so our numbers match. Okay, so if I want to know how much data is within 1 standard deviation, first I have to calculate that. So 15.8, and if I want within 1 standard deviation of that, well, 15.8 minus 1.2, we're talking about going from 14.6 up to 15.8 plus 1.2 up to 17. All right. So now what we're going to do is we're going to go back to our list. Okay. So back to this list right here, and we're looking for values between 14.6 up to 17. Okay, that is within one standard deviation of our mean. So let's see where all of those are. So 14.6, 14.7, 15.1, 15.2, 15.3, 15.4. All right. So how much of the data? Well, I'm counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So we have 25 of our 36 data points within one standard deviation. So 25 out of 36, that is roughly 69% of our data. And you know, that is really close to the 68% that we were looking for. So I'd say that is a pretty good match so far. All right, now within two standard deviations. So our next one, 15.8 plus or minus 2 standard deviations. So let's see how much we're encompassing now. So 15.8 minus 2.4. So now we're looking between 13.4 up to 18.2. All right, so coming back here again, so this time we're looking for 13.4 up to 18.2. So let's see how much more data we can include now. Okay, so we can include all of these now, and we can include up to there. So now all but 2 of our data points are within 2 standard deviations. So instead of counting it all up, hopefully you can see that that's going to be 34. Okay, all but 2 of them is going to be 34 of our 36 data points. So again, let's calculate that percentage. And I'm seeing 94% of our data is within one standard, or is within 2 standard deviations here. And finally, let's do within 3 standard deviations. Okay, so within 3, 15.8 minus 3.6, we're going from 12.2 up to 15.8 plus 3.6 up to 19.4. If you go back and you look at our data, you're going to see everything is encompassed now. All 36 data points are within one standard deviation, or within 3 standard deviations, sorry. So if you notice, this very closely models that 68, 95, 99.7 rule. So I would say this is, again, very convincing that this is coming from a normal distribution. This data is normal. There is one last check that we can do, okay? That last check is to make what's called a normal probability plot, okay? So normal probability plot essentially places the z-score on the vertical axis with the data on the horizontal axis. Now the neat thing is your calculator is already programmed to do this for you. Okay, normal probability plot. Let's go into stat plot. Remember, any graphical representation That's what we're looking for. Going to stat plot. It's already on. The normal probability plot is going to be that right there, that last one. Okay. And if you zoom stat it, you're going to see this. It looks like a scatter plot, okay? And again, what the normal probability plot is placing the data values here and their z-scores there, okay? Now, the nice thing is this is not an AP test topic, okay? You will never have to know how to make one. They won't even ask you to assess this, okay? But basically all you're looking for is a linear pattern, okay? If this can be approximated by a line, then that is indicating it is coming from normal data, okay? If you see non-linear scatter here, it means it is not normal data, okay? So while this not used is not assessed on the AP test, feel free to use it though, okay? On a free response question, if you need to assess the normality of something and you want to use a normal probability plot, perfect, okay? If you don't want to, you can use one of the other methods that I just showed you to kind of convince yourself and convince the AP test reader that you know what it means to be normal, okay? So otherwise, that is going to be all for today's notes. So thank you for joining me, and make sure that you let me know if you have any questions from these notes.